Good afternoon to you. Mark Stott with HurricaneTrack here. Saturday now, the 9th of August, 2025. Good to be with you this weekend. Just got back from my trip to the desert Southwest. And lo and behold, we have Invest Area 97L. Lots of questions about it, I'm sure. Lots of information already flowing out there at the speed of light. So I figured, hey, look, why don't we break it down into what we know versus what we don't know. And hopefully by the end of today's update, I will have given you a few sort of vantage points to look at this from over the coming days, because this is going to be with us for quite a while. Probably going to be our first hurricane. And by the way, once it does get a name, assuming it does so, the name will be Aaron with an E. So let's get started. National Hurricane Center homepage. There's 96L. Don't worry about it. Had it shot. Too much dry air, whatever. It's not going to do anything. This, however, Invest Area AL97. We just shorten it to 97L. Just easier, I guess. 10% and 50% over the next 2 and 7 days, respectively. Well on its way, eventually, to becoming, more than likely, the first hurricane of the season. So, as promised, we're going to look at this from two vantage points. What we know versus what we don't know. So let's look at the obvious stuff. First, a close-up of our system off the coast of Africa. A vigorous tropical wave sitting out here, obvious rotation with it, a few popcorn areas of showers and thunderstorms, but nothing particularly organized just yet. After all, it is in its very early stages of development. We can broaden the visible satellite shot out, or the true color as it were, and there it is, sitting off the coast of Africa. It has a very nice inflow tail in here, feeding it some of that moisture out of the intertropical convergence zone. There is, however, the ever-present dust and dry air sitting in the vicinity, so that could help to stunt the development of this system a little bit as it moves off the overall envelope of energy, generally in this direction, which brings me to the first sort of clue here. We're not quite to the what we don't know yet. We're still in the what we do know, right? And what we know, we got this big area of energy. But I'll tell you, the first clue, the quicker it develops, the more likely it is to stay more to the north. It's just the way the atmosphere works. If it's deeper in the atmosphere, fills up more of the atmosphere, it will feel any weakness in the subtropical ridge, and it will gain latitude. The shallower it remains in the atmosphere, in other words, weaker, the more west that it will go. So this does work in the what we know part, because right now, we know that it is generally shallow, it's organizing, and it's not a deep hurricane or anything like that. So that's the first clue here. The quicker this develops, the more likely it is that it'll avoid the islands of the Caribbean there, and maybe even points farther to the west. That is so far out in time, nobody can tell you for sure what's going to happen a week from now, and even further out in time than that, right? So, that's part of what we do know. Let's look at some other things that we know currently. The vorticity signature on it, boy, you know how I like this product. Very robust, sitting right there. And then there's other energy around, but that is the signature that we look for. There's your fingerprint, so to speak. So we're going to watch this, and let's track it over the coming days. I'll be here every day from here on out. And let's see how this goes. Does it go more west like this? Does it start to gain latitude quicker? Does it pivot around the larger gyre that is sitting out here? And we're starting to bleed into the what we don't know part. But this is interesting because we can definitely track that feature right there over the coming days and see how it organizes and where it is in relation to the latitude line sitting out here. All right, so this will be easy going forward. Yeah, generally. Also, what we do know, water temperatures out here, anything in yellow, and I will highlight it in this blue so it'll stand out. So here's your, basically your 26 degree isotherm right here. Isotherm is line of equal temperature, roughly 26 degrees or about 80 degrees Fahrenheit. Our system is sitting right in here. Clearly it is in water, or over water, that is warm enough to support tropical cyclone development. And whatever the track area is over the coming days, it'll just get into an environment with warmer and warmer water out in front of it. Again, part of what we already know. All right, so I told you the first part's easy. The other part that we do know, the anomalies sitting out here, a little bit warmer than average, but much more so as you get farther to the west, and especially if it gets over into this neck of the woods. Water temperatures are not only warm, but they are at least a degree Celsius warmer than the long-term average. Now, let's get to the hard part, what we don't know. So for that, let's jump over to the dashboard here at Tropical Tidbits, and these are the various features that Dr. Cowan has provided to us. This is interesting. So let's look at the GFS ensembles, because this paints a picture right out of the gate of, oh, it looks like it's going to curve on out into the Atlantic and not affect anybody. Well, let's look at the timestamps on here. All of the ending points here are 240 hours out. Now, if memory serves, that is 10 days. Anybody that thinks that computer models are going to nail any one of those ensemble members 10 days out, well, you're wrong, because we are not there yet with the science. Even the next few days, the envelope of potential track areas is fairly wide, and 3 or 4 days from now, that's really going to matter, because again, the faster this develops, the deeper it fills the atmosphere, the more likely it is to take one of these more northerly tracks, feeling any weakness at all in the subtropical ridge sitting out here. So what we don't know is also pretty obvious and pretty easy. We don't know the long wave pattern of the atmosphere going out 10 days, and we don't even know about short wave troughs. When I say long wave, generally we're going to get like a deep trough or a more short wave trough that carves away the ridge a little bit. We don't know any of this stuff more than about 5 days out reliably. So ensembles are helpful. Individual operational model runs, a little bit helpful, but when you see something like this and you see an immediate dismission, I guess, you see somebody quickly dismiss it, that's the word I'm looking for, as curving out into the Atlantic fish storm, and there's the mean right through there. I'll draw it in blue. So that would indicate, yep, this is probably turning on out into the open Atlantic, not going to bother anybody. Well, that's 10 days out. How many times have we seen this? Right? How many times have we seen it? And it comes more and more west. The ensembles, everything over time. Now look, truth be told, the same exact wording would have to be said if all of these ensemble members were generally much more to the west. And I can show you some examples of the danger of looking at long-term guidance and making a deterministic stance on, oh, it's a fish storm, it's turning out to sea, which is the same thing I would say if it looked like it was going to plow right into land areas. We don't know for sure. So this is definitely part of what we don't know, right? So let's switch from the ensembles. Let me show you the operational. So this is today's run, the 12Z from today, meaning it was initialized at 8 a.m. Eastern Time. There's our feature sitting right here, the vorticity signature, very well captured by the model from satellite data. So let's watch how this evolves over the next 10 days, because that's what the ensemble shows. And I'm going to show you the danger inherently in really focusing on anything beyond 5 days. So let's watch this as I put it into motion. It quickly pivots around this larger gyre sitting down here. The little area of concentrated vorticity kind of pivots to the northwest, and then it gets started and starts this trek to the west, even maybe losing a little latitude in there once in a while, but whatever. So then it steams on to the west. We're out at a week's time, and it is well northeast of the islands. Now, this is the first juncture that I want to bring up in terms of, yeah, it's likely this will happen. I mean, it makes sense, but if this does not gain that latitude right there and then start the trek west and it's further south, we're going to have some problems over here. So the first 3 days of this are going to be very, very important. Where does it really start to come together? Does it happen north of the Cabo Verdes, west of there? We don't know. Again, that's why this part is called What We Don't Know. But we can track this. That's what's going to be so fascinating and helpful, is we'll actually be able to see this evolve in real time. So let's back it up, and I'll show you what I mean about this. You see where it is now. It moves to the northwest through the Cabo Verde Islands, Cape Verde Islands, whatever you want to call it. Then it starts to move on, and the GFS starts to develop it pretty quickly there. Small little cyclone sitting in the field, the 850 field. But again, this is even, 108, 120 hours out. That's 5 days. It could be a couple hundred miles either side of this, honestly. So beyond that time, worrying about it anywhere from Nova Scotia to Houston is just futile. Like, forget it. Watch it, but don't get upset. Don't worry about it if you see a run. Like, let me show you this. 24 hours ago, this thing plowed in and went on into Houston, right? That was a day ago. And this is very important in understanding the limitations of numerical weather prediction. Just one day ago, this was the solution. Same kind of thing going northwest there through the Cabo Verdes. It gets cranked and it gets moving and it's almost due west, almost like an Ike track, but not quite, through the Florida Straits and then right into near Houston, Freeport, somewhere near there. So what changed? Well, nothing changed in the first part of it, really, because the atmosphere hasn't had much time to change. But in the long term, clearly the model was, quote, seeing more ridging 24 hours ago than it is today. So here's the danger. Today, we go to the 12Z run, and I'll finish it for you, and it moves generally like, oh, that's a close shave. So to think that, oh, that's the new solution now and that's going to be what happens is foolish. Just like yesterday saying that this run is going to be the end game would also have been foolish, right? We don't know the long-term pattern of the upper air situation, troughs, ridges, what even happens in the Pacific has a bullwhip effect downstream. This is just going to be one of those deals, as you know, we're going to have to just watch and wait and see, because my goodness, this far out in time, even a week out, let's go to 168, because that's what we do have these days is 168-hour guidance, generally from the National Hurricane Center. It could be much further south and west, or maybe even more to the north and east than what we're seeing here. So, yeah, we have some limitations there. And even the euro, let's switch over to that. A lot of people have a lot of faith in the euro. This is last night's run, the 0Z. We don't have the 12Z yet, so we'll show you the 0Z. Euro, very similar evolution, just not quite as organized. There it is right in there. I'll back it up just so you know what you're looking at. Watch it. See that vorticity signature? Takes it longer to organize, so it stays a little bit more to the south. And on the euro, it is able to come in and get very close to Hatteras and vicinity, and then it comes across Cape Cod and into Maine of all places. But again, look at the timestamp, 342 hours out. This is why we cannot trust the model guidance that far out. It's literally like having a smoke plume, and when it's close to you, it's very tight and clustered. Then as it goes out further, it disperses more and widens, and all sorts of weird things happen, what we call perturbations. The perturbations in the modeling, everything is just far too complex. AI models that are starting up, Google DeepMind and others that are out there, they're not going to have a good grasp on this either. Look, it's just one of those things. Unfortunately, we're stuck in about a 5 to 7 day time frame where it's generally reliable in terms of what the forecast is going to be. So and I want to show you these long range outputs to explain them, that you can get these very vast and different runs from the various models, right? And most people know that, but some people have no idea how this stuff works at all, and they see something like that, and they go, oh my goodness, I'm going to cancel my plans to go to the Outer Banks. Don't. Because that's 300 hours out. It could be farther to the south by 500 miles. It could be over Bermuda. We don't know. That is why I said what we don't know. We don't know if this is going to happen, right? Just like we don't know what I showed you from the GFS and its solutions just 24 hours ago that this ends up in Houston and vicinity. We don't know. All right? So don't sweat it right now. It is hurricane season. We all know that. So we have to watch. We have to wait. But don't fret over it. When you see either one of those deterministic statements being made, it's a fish storm, which is a ludicrous statement because hurricanes are above the ocean and the fish could not care any less. More than likely, I haven't polled any fish to ask them But I get it. I know what people are saying. I'm probably being too nitpicky. But look, a fish storm versus, oh, it's going to Houston, both ludicrous and outrageous statements this early in the game. And most of us know this. But I just wanted to remind you, there's definitely a what we know and a what we don't know. And I'll try to do my best to explain it all as we go forward. But for the next couple of days, we will watch the genesis of this feature take shape, and we will take it from there. All right? So let's do this again tomorrow and look at what we know versus what we don't know. I think that's a good game plan. Until then, have yourselves a great rest of your Saturday. And as always, thanks for tuning in. I am Mark South from all of us at HurricaneTrack. Good to be back with you here from back home. I'll do it again with you tomorrow.